discussion for question 4 in engineering mathematics. Before that, we are going to introduce ourselves.
My name is Muhammad Binali.
My name is Ember Farani.
My name is Eramin Anaeri.
My name is Mr. Jerry.
That's all from us. Thank you.
Introduction: the metric to division of set number or similar division in a regular shape in vertical and horizontal lines of their element or argument in row and columns. They are useful of the regression system of linear differential equation as well as representing linear application. In linear algebra, an identity metric is a metric of order n times n mass that is must mean diagonal element is equal to 1 and the remaining element of the metric equal to 0. As we know, the identity metric as a whole is mean diagonal element 0. As well to create an identity metric of order 4 by 4, we with the metric element is 4 and columns and give 0 and also be enclosed with column. First 1 0 0 0 1 0 0 0 0 1 0 0 0 0 1. For example, for order unit matrix solution, the unit matrix is the one having one's order mean diagonal and other interest as zeros. Thus, the unit matrix of order 4 type order or division metric of order 4 can be written as column 1 0 0, column 2 0 1 0 0, and column 3 0 0 1 0, and column 4 0 0 1.
Problem solving. Question 4. A. The current in the various branches of the circuit I1 and I2 applying Ohm's law and Kirchhoff's law result to the junction of path is given by. So this is an example question. If you see here, we have 2 I1 negative 5 I2 equal to negative 15, and the second column I1 plus 3 I2 equal to negative 2. So how we solving this method is by using inverse matrix method. So the first step is we must do open bracket and we put 2 1 negative 5 3 close bracket and open bracket. Also I1 I2 close bracket equal open bracket negative 15 negative 2. So the next step is we must do in the second method lah. I1 equal to I1 I2 equal to 1 over AD minus BC open bracket D negative C negative B A close bracket open bracket negative 15 negative 2. If you see here, we also do the same method equal to 1 over 2, open bracket 3, close bracket, negative, open bracket, negative 5, close bracket, open bracket 1, and close bracket again. So, open bracket 3, negative 1, 5, 2, close bracket, open bracket, negative 15, negative 2. So the next step is equal to 1 over 11, open bracket 3, open bracket, negative 15, close bracket, plus 5, open bracket, negative 2, close bracket, and we close again. Negative 1, open bracket, 2, close bracket, plus 2, open bracket, negative 2, and close bracket. Then equal to 1 over 11, open bracket, negative 15, 11, close bracket, and finally we have negative 5, 1. So the answer for I1 is negative 5 and the answer of I2 is 1, positive 1. That's all for question A.
I want to present about the next question, that is question 4b. For question B, solve the following 3 linear equations by using Cramer's rule method. For the question given is in row 1, x plus 2y plus 3z equals negative 5. For row 2, 3x plus y negative 3z equals 4, and the third row is negative 3x plus 4y plus 7 equals negative 7. We need to put the number inside the metric forms, means from the 3 linear equation in the question. So, this is the step for making the data 0. Put the number in the bracket. For the first row 1, 1, 2, 3. The second row is 3, 1, negative 3, and the third row negative 3, 4, and 7 equals 1 in the brackets, 1, negative 3, 4, and 7. Close the bracket. For the second step is number 2. Open the bracket and put the number in the first row, 3 and negative 3, and the second row is negative 3 and 7. Close the bracket, and the third row is 3 and 1, and the negative 3 and 4. Close the bracket. For the next step, we are going to using the formula that is AD minus BC. We are going to do the method equals 1 in bracket, 7 negative minus 12, close the bracket, and negative 2 in bracket, 21 minus 9, close the bracket, plus 3, open the bracket, with 12 negative minus 3, close the bracket, and the answer is 40. For the next data x, data y, and data z, we are going to use the same method and formula. The answer for delta x is negative 40, for delta y is 40, and delta z is negative 80. After we get all the answer, we need to find the final answer, that is x, y, and z. For getting the answer for the x, we need to divide the delta x with the delta 0. That's it. Delta x equals negative 40 divided by delta 0, that is 40, equals negative 1. For delta y, we would need to divide the answer 40 divided by 40, that's answer is 1. And for z, we need to divide the answer of delta z, negative 80 divided by 40, the answer is negative 2.
Question C. Prove the following law of matrices. In bracket AB transpose equal to B transpose A transpose. If A open in bracket 2, 5, negative 3, 7, 6, 2 and B in bracket negative 1, 2, 7, 3, negative 5, 4. Verify that in bracket A plus B transpose equal to A transpose plus B transpose. Given A in bracket 2, 5, negative 3, 7, 6, 2 and B equal to negative 1, 3, 2, negative 5, 7, 4. If A transpose equal to 2, 5, negative 3, 7, 6, 2, BT, that means B transpose in bracket negative 1, 2, 7, 3, negative 5, 4. So A plus B is 2, 5, negative 3, 7, 6, 2 plus in bracket negative 1, 3, 2, negative 5, 7, 4. So after that in bracket 2 negative 1 plus 5 plus 2 negative 3 plus 7 plus 3 6 minus 5 2 plus 4. So A plus B in bracket 1 10 7 1 4 6 in bracket A plus B transpose 1 7 4 10 1 6 RHS A transpose plus B transpose in bracket 2 7 6 5 2 7 5 6 negative 3 2 plus in bracket negative 1 2 negative 3 3 negative 5 4. So A transpose plus B transpose in bracket 2 minus 1 7 plus 3 5 plus 2 6 minus 5 negative 3 plus 7 2 plus 4. So A transpose plus B transpose in bracket 1 7 4 10 1 6 in bracket AB transpose equal to BT 80. That's all for question C. Tiga.
In conclusion, there are numerous applications of matrices both in mathematics and other science. Some of them merely take advantage of the complex representation of a set of numbers in matrix. Firstly, matrices are used in geology to conduct seismic surveys. They are used to create graphs, statistics, calculate, and conduct scientific study and research in a variety of subjects. After that, matrix multiplication is used to plot graph of data, render graphical image, analyze the product of model electrical circuits, guide robot and aircraft. The blood scan used in health, encrypt message, facilitate the process of electronic communication, and perform statistics. In addition, matrices are used in linear algebra to solve systems of equations, to find eigenvalues and eigenvectors, and to perform other mathematical operations. Then, matrices are used in engineering to solve problems involving linear equations and to model physical systems.